All right, beautiful people. So today our essential question is, how do we use GCF, or the greatest common factor, to factor algebraic and numerical expressions? So we're going to start with numerical expressions. So let's just remind ourselves that a numerical expression is an expression that has only numbers and operations, which of course you guys remember. So if you really remembered what a numerical expression is, then you don't really have to write that definition. But here's an example: 15 plus 12, 2 times 3 divided by 6, etc. Okay, those are numerical expressions. So we're going to talk about factoring numerical expressions. So we're going to factor a numerical expression, and we're going to remember from yesterday, or the last day, that when we're factoring expressions, it's basically the same as just factoring two numbers. So we're going to start with the 220 minus 12. This is a numerical expression, and we're going to factor it. So when we factor expressions, we're going to keep them with the addition or the subtraction sign in between, okay? And all we're doing is we need to first find the GCF. And if you recall from Friday, to find the GCF, we're going to use the ladder method. So I'm going to make a ladder. All right, and then I think, what number divides 20 that also divides 12? There are a few. I'm going to go with 2 because I noticed that 20 and 12 are both even. Another number you could have chosen was 4. 4 would have also worked. Okay, so then I do 20 divided by 2 is 10. And then 12 divided by 2 is 6. Okay, and then I'm going to keep the subtraction in between. All right, 10 and 6 share another common factor, so I'm going to make another rung on my ladder. So 10 and 6, what number will divide 10 and 6? 2 again will also work. So then I do 10 divided by 2 is 5, and 6 divided by 2 is 3. And then I keep the subtraction sign in between. So notice this time, since we're not just factoring numbers, we're going to keep the subtraction sign throughout the entire expression. Okay. So then now we can find the GCF. So the GCF, or the greatest common factor, is 2 times 2, which is 4. Okay. So this means that in order to get to 5 minus 3, I need to divide by 4. So I'm going to keep this 4 because that's my greatest common factor. And then the stuff that would be on the inside is 5 minus 3. So I've factored 20 minus 12. Okay, these two expressions should be equivalent. So that means that if I solve the expression on the left-hand side, this should be the same as the expression on the right-hand side. These two things are equivalent. Okay. And that's true because whenever I pulled a number out, I divided the original two numbers by that number that I pulled out. So when I pulled out 2 from 20 and 12, I divided to get 10 and 6. When I pulled out 2 again, I divided to get 5 and 3. So when you factor an expression, you're basically finding the GCF, and now we get to use the stuff on the bottom. This is the expression inside the parentheses. Okay. When we factor, we make it look like a distributive property problem. So factoring results in an expression that looks like distributive property. And you're going to notice that because, hey, this looks a lot like distributive property. You got a number on the outside of parentheses. There's a little hidden multiplication sign. You've got two numbers inside the parentheses that are either added or subtracted or something else in between. Okay, so when you factor, you're just making something look like distributive property. So we're going backwards from distributing. So if we were distributing, we would be multiplying through to get 20 minus 12. But now that we're factoring, we're dividing out. Okay, because to factor means to divide. So here's another note that I'm going to make. Factor means divide. Okay, so we've written a lot just for this first example.